right, so today we're going to take a look at section 10.3, and really you could put 10.2 and 10.3 all together. It's all about displaying data. They've arbitrarily decided to put part of it in section 3, part of it in section 2, and so this is really just a continuation from last time, different displays of data. So the first one that we're going to take a look at is a line graph, and this isn't like a dot plot or a line plot, it's actually a line graph. This actually is a good way to think about something that does change over time. Or maybe even stays the same over time, but it looks at something that is trending usually over time. So there are line segments that connect one data point to the next, typically showing trend of data over time. For example, let me take a look at this one. A learning specialist tracked the average reported study times of her students. Create a line graph for the data that she tracked. So the first thing we're going to do is we're going to create our X and our Y axis. And this actually kind of goes back to Haley's question. Our x-axis in this case is actually not going to be a number. What's going to go on my x-axis? The days. So they're actually not numerical data on that, but that's okay. So we're going to put our days. This is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. All right. And then what's going to go on my y-axis? A numbers of hours, right? What's the smallest number of hours you see up here? 0.25. What's the largest number? 2. So how do you think might make sense? And there's more than one right answer, but how do you think might make sense to do my x or my y-axis? By quarters, because I see some quarters in there. I don't see anything any more specific than quarters, right? So I'm going to do my axis with increments in quarters. So I'm going to do 25, 50, 75, 1, 125, 150, 175, and 2. Again, you don't have to label all of them, but you should label at least a few of them in there so we have some perspective. Maybe I'll label every half increment. Now we're going to plot some data in a minute, but I need a couple things more. What do I need? I need a title for my graph. What does this title for my graph look like?
Average reported study times.
Okay, sounds good. Let's get the average reported, let's say daily study times. What else do I need? I need to label my axis. So on the bottom, what I'm going to label my horizontal axis. The days. If you want to say days of the week, that's fine. You can write days. What about my vertical axis? Hours. This is hours. If you want to be really specific, you could actually put hours studying. We've already put studying down in our title, so if you don't, that's okay. And then we're going to put a plot, a dot, for every single one of these data points. So on Monday, it's supposed to be at 1.5 hours, so we're at about right here. On Tuesday, 1.75. On Wednesday, I'm at 0.75. They all went to church, right? Of course. On Thursday, apparently all studying for the test that happens on Friday. On Friday, hello. I think that actually is probably the high estimate, if you want to be honest, right? Do you know any children who study on Friday night? All right, so Friday is 0.25. Saturday, also 0.25. And then on Sunday, we're back up at 1.5 because school's about to start and we've got to make up for everything we didn't do over the weekend. All right. Now, what a line graph does is it connects these, connect the dots. Okay? So I'm not trying to fit some sort of a line to the data. I'm actually going to draw one dot connected straight to the next dot. So these are going to be straight line segments that are going to connect these dots. So we're going to draw from Monday to Tuesday, Tuesday to Wednesday, and so forth. and that's a line graph. Can you think of any places in real life where you've seen line graphs used outside the classroom? Stock market's probably the classic one, yeah, stock market. The good ones, you can see this, and they're connected like this, right? I mean, like we can look at a trend line that's nice and sort of overarching, you know, what's it done over time, sort of on average, but this is how you usually see them done, don't you? And you also look at different statistics that are done, like if you're looking at things that are maybe comparing childhood obesity, right? And they'll show lines like this. So there's lots of things that are done in media that are shown with line graphs. Okay, the next one is a scatter plot. We've actually created a scatter plot already. A scatter plot is just the same thing we did on the previous slide, but without the lines on it. Okay, you guys have created scatter plots like since you learned how to plot points. You just didn't know what they were called. All right, so this is often used when a relationship cannot be easily depicted even by a broken line. Coach Lewis, and that doesn't necessarily mean that the example has that feature, but that's often when it's used. Okay. We can create a scatter plot for any set of data. Coach Lewis kept track of the basketball team's jumping records for a 7-year period as follows. Draw a scatter plot for the data. What kind of association is there for this data? So we'll talk about the association in a minute, but let's do our scatter plot. So the scatter plot will start out just like it did on the previous one. What's going to go on my axis? Years on bottom. Now, one comment I'd like to make is on the bottom here, in fact, let me undo my line that I just drew. On the bottom of this, I'm going to start with the year 2000. Okay, that's where I'm going to draw this in. But that doesn't recognize that, I mean, like he only started keeping track in 2000. I mean, there were probably some jumping records that happened before he was keeping track that we're not recording here, correct? So there's sort of this arbitrary starting point that we've chosen as the year 2000. Agreed? So what you do to make sure that that is indicated properly is that you draw a, I don't know, kind of a squiggle, and then you draw your horizontal straight line. Okay, it shows that you're breaking this point in time. It doesn't actually start at 0, okay? And that way, after this, whenever I draw my year 2000, I can actually start looking at making the values between them equal increments. So this is 01, 2, 03, we get to 06, 04, 05, and 06. Your line will be undoubtedly straighter than mine, though. It's really not good. All right, so what else do we need next before I start actually? I need one more. I need something over here, right? Yes. What's my smallest value? And my largest? Okay, so I'm going to have to do on the vertical axis exactly what I just did on the horizontal axis. Because you see, if I'm actually on the horizontal axis, that's supposed to be 0. Make sense? But I don't really want it to start at 0, and I don't want there to be any sort of implication that has scale issues going on. We're going to talk when we get to section 10.5 about some weird things that can happen. But I want to show that there's a break in my values here too. So I need to have this line come down and to show that there's a break right here. I'm not starting at 0, in other words. Wherever I draw my starting part is not going to indicate that 0 is included. So I'm going to include 65 because that's my smallest. And then I'm going to go up from there, and I need to go up to 77. So I'm just going to mark them off in ones, let's say. 66, 67, 68, 69, 70. 1, 2, 3, 4, 5. 6 and 7. Out of space, just barely. Now what? Before my points. I want to label some stuff, just so that I don't forget to do it. So what would you like me to label, Grant?
You can start with the axis.
Okay, which axis do you want to start with?
Vertical.
Vertical, so what's going on this vertical axis?
Inches.
All right, so this is inches. We have to have at least the units that are going on. If you want to be specific, you could actually say jump record in inches, but our title could also do that for us, so we can take care of that there. What's my horizontal axis going to be labeled? Years. And my title? Yeah. All right, so we don't really need the 7-year part because we've got the 7 years displayed, so we don't have to have that. So this is the basketball teams. Jumping record. Then we can plot points like Haley said, right? There's red plots of points. Okay. So we've got year 2000, we've got 65. The year 2001, we've got 67. Where I am. 5. The year 2002, it's at 67 again. 2003, it's at 68. 2004, it's at 70. 05, it's at 74. When they brought in some really tall folks, or folks who could jump really well there last year. And then in 06, it's at 77. Crazy, right? Okay, so this is a scatter plot. Cool. All right, so this is a scatter plot. Let's take a look at the next slide here. A trend line is a line that tries to estimate the scatter plot with an actual line. This is not a line graph. The line graph has these line segments that are all part of it, right? We saw that on the first example. A trend line is actually one fluid line, not a bunch of line segments all connected. And so we're going to take a look at example 2. We're going to go back and try to create our best trend line. And as we do this, I want to actually show you a couple features of Smartboard, okay? So we'll see if I can find them, because every time I start looking, I start wondering where I found them. Did I write it down? That's a good question. Probably not. All right, so let me go to the end here and add a slide. Okay. I have somewhere in here, right where they are. That's not it. There's an app. Graph paper. All right, so I'm going to go back and I'm going to draw that same set of data with the graph paper. I'm not going to label everything because my point is to show you how to do the trend lines on this one. Okay, so we had 2000, we had 01, 02, 03, 04, 05, and 06. And then we had, we'll start here with 65, 66, 67, 68, 69, 70, 1, 2, 3, 4, and 5, 6, and 7, which is where we stopped actually. First one was 65. Where's the next one? 66? 67. 67.
67.
Okay.
68. 70. 74. 77.
Okay. How nice is that? I'm going to show it in the very end. If you have graph paper and you'd like to use it, that'd be great. If not, you're going to just have to do as accurate as you can with what you're given. So the whole point in doing a trend line is trying to take a line that best estimates this. So maybe you've done this before in chemistry. I That's where I first saw it probably in high school was in chemistry. But our goal is to create a line that will get as close as possible to all the dots. And there are ways to do this mathematically to find that exact line. That's not what we're working on here. We're looking for a best estimate visually. So we're trying to draw a line that gets as close as we can to most of the dots. And since we're doing it freehand, so to speak, is Miranda's line going to match Marissa's line? Probably not exactly. But there are some things that it better have in common. For instance, what can you tell me about the slope of this line? It's positive. So if one of you gets positive, one of you gets negative, you've got a problem. Okay, so there are some things that we can say for sure about it. We have a positive slope. So do you remember finding slopes of lines? Because the next thing we're supposed to do after we found it, so this one says create the best fit line, the trend line, which we just did. We visually did that. Part B, though, says to estimate the trend lines equation. So we're actually supposed to give an equation for the line, and my equation better match my line, and your equation better match your line. Okay? So, taking a look at this, I know I've got to start with y equals. What do you need as a part of a line? Slope and y-intercept. And you may have seen the line written like this before as a common way of writing it. What is m? That's my slope. So that, and what is slope of a line? What does it actually mean? Rise over run is about steepness, and Whitney's giving me the way of finding it. Okay, so here's the trick, is that when we're looking at this, we need to use the line to do it and not the data points to do it. Are you with me? So don't just take two of the dots that are on here and find the slope between them. We need the slope of the line. Now, visually, we can take any points on the line that we want. So some points are nicer to take than others. Now, since I've got it on a grid, anything that crosses at the corner of the grid is going to be a fairly nice point to use. Make sense? So I don't know about you, but I'm a big fan of this particular point right here. Because it even hits an axis and it's on a corner and all that's really good. And maybe you pick, you can pick any other point you'd like, but maybe you decide, 06, yeah, that one looks pretty good too. So let's actually write down what these coordinates are. We'll do 06 first since Kayla had just mentioned that one. What does that one look like, Kayla? It's 06, so we'll write 6, and then what? 75. And then down here, what's this one? 0, right? Because I got it at the year 0. That's the way I'm measuring. And then what's it? 64. The way I've drawn this in, that is 64 because of the way I've scaled my y-axis. Everybody good with that? Now, Whitney, I'm going to let you tell me how do I find slope because you're about to move forward. Okay. Yes, so we have a change in y over the change in x. So we subtract y values. We just need to make sure we do it in the same order. So if I decide that I want to start here with a y value, what's my y value at this particular point? 64. And I subtract my y value at this point, which is 75. And could I have done it in the other order? Sure. You just have to make sure you go in the same order on top and bottom. So down here again, my x value is 0, right? Yeah. And my y value is 6. So what's 64 minus 75? Negative 11. And my denominator? Negative 6. Do we write negatives over negatives? Not usually. What should we write instead? 11 over 6 would be more reasonable. Now, I guarantee that if I look at my paper, 11 over 6 is not what I have. Just so you know, I have 4/3 when I did it on this piece of paper. Okay? So it actually ended up being a fair bit steeper. But the number is actually still between 1 and 2, isn't it? So we're kind of looking for a ballpark number here. That's okay. All right, so my equation so far, I found 11/6 of x. Now I need the y-intercept according to my line that I drew, and I actually don't even have it drawn quite in, but could I? Yeah. Sure, I just need to extend this guy without disturbing anything else. Looks pretty good. Where would this look like right here that's about crossing if you count down?
63.
It's 62. I know I'm beneath my x-axis, but remember my x-axis is not 0 here, is it? It's actually 64, the way that I've done my increments. So this is 65, 64, 63, and it would be 62. Is everybody okay with that? 62, all right? So this would be plus 62. And somewhere in here, I've got to use a little bit of language, okay? So let me copy this and put it on the slide where it was supposed to have gone. All right, so there's the equation. This equation has no meaning if I just tell you that the equation is 11 over 6x plus 62. Not very informative. What in the world did I find? Well, using that chart or that table that I created, this graph, what does this table get, this graph get me? What am I finding? What's the title of it? It's the jumping record, and the jumping record is given in inches. This tells me the inches or how high somebody jumped in a particular year, correct? And that's what this equation is supposed to be telling me. So what I need to do at the back side here is to write down that this is inches. At the very least, you got to write down that it's inches. That's how I'm measuring this height. If you want to write down something with a jumping record, that'd be a good idea. Inches of your jump height. And I need to figure out what in the world X is representing, because you see, when I created this line, when I created my chart and when I created my equation and I actually did something that you guys probably weren't aware that I did, is that I made the year 2000 a lot like that it was the year 0, didn't I? I mean, that's how I acted, because it was convenient to do so, right? But if I want to know what happens in the year 2010, I have to somehow let whoever's looking at this equation know that they need to put the number 10 in for X, not the number 2010. Do you see what I mean? Because I let X equals 0 be the year 2000. So there's a couple of ways to write that. You could actually say what I just said. You could say for X equals 0 is the year 2000. Some of you like that. You know what? Actually, I made an error when I did that. Think about that. I actually didn't do it in the year 2000, did I? What did I say my y-intercept was? I didn't realize I was doing it when I did it.
64, which would have been like...
I said my y-intercept was 62, didn't I? But that would have been in 1999, wouldn't it? So the way that I drew this, the easiest fix, you want to know what the easiest fix is at this point? Can I move my axis? We'll see if the smart board will let me. But that's my easiest fix, and I'll show you what we can do. Is that, well, give me a second, I'll show you. I won't be confused when I fix it. How's that? This is my easy fix. What would that make my y-intercept? Close. Yeah, it was 64, sorry. I was thinking 65, but you're right, it was 64. And then I can still measure it since the year 2000. So now the year 2000 really is the number 0. That's probably the easiest fix for how we did it. It makes the most sense to talk about the year 0 being the year 2000. The other way we could label this at the end, right here, is instead of saying this piece, we could say something like this. X years after 2000. So X is just the time span that has lapsed since the year 2000, wherever you are. So if you want to know about 2015, you got 15. Yes, David. Ask the question one more time. I'm not sure I follow it. That's true. You would, except for your y-intercept would be different. Your y-intercept is related to wherever the year is used. start with the year, and I made my drawing originally, but I actually started in the year 1999. Another picture tonight. Yeah, and it's a little bit easier to think about that starting year 2000. If you want to do it with where X is the year, you're going to have to go with your line clear back to the year 0 and to the with the Y intercept was year 0. First of all, it's sort of impractical to draw the line back that far. And secondly, it's going to sound funny because obviously the trend line is not going to make sense back in the year 0 for many reasons. Number one, it's going to be negative. Right. Negative jumping record. Yes, that sounds great. Yeah, so having the starting year be the start of your data or close to the start of your data is the most reasonable way to approach it. And we could have stuck with the 1999. I mean, that would be okay, but it starts being awkward because if somebody wants to put a number into this and I say that it's the number of years since 1999 and I'm talking about the year 2012, you have to stop and think a little bit more than if I start in the year 2000, right? It's just awkward to start in 1999. Are you guys with me on that? And I drew my graph to represent starting wrong. So, all right.
But you could just keep everything the same and just put X years after 1999.
Yeah, you could have.
Fine.
Yeah, the graphing would have been fine. If we'd left it as it was, we could have said X years after 1999 and it would have worked just fine. Yes?
Could we find the y-intercept by just plugging in points and like using the equation, or do we have to draw it?
You can, as long as the point that you're using is actually measuring up to how your graph is done. So for instance, when we looked back at my graph, we recognized, oh, that was the year 1999. So yes, you could have operated from that, but it's going to be difficult to sort of plug points back in because you're plugging back into an incomplete equation. So I'm not sure how effective that's going to be. There was one thing that we forgot on the last slide. I told you we were going to do it, and I never did it over here. And let me make mention of it. It was the association question. You guys didn't notice I forgot it, did I? No, not at all. It's okay. Association has to do with slope, and we just found the slope. Association has to do with whether or not the slope is positive or negative. In other words, is something increasing or decreasing over time? So looking at this data, without even the trend line drawn, you can tell me that the association is positive. This is an increasing value over time. So the association has to be the words positive or negative. It's not increasing or decreasing. It's positive or negative. And you can see it, of course, once you've created the equation, that, of course, the slope was positive. So the association, the phrase association, has to do with the words positive or negative, and it talks about the positive or negative of the slope. All right, and then we're going to do this very last part, which is why we needed this information about what my starting year was. So using your equation, what would you predict the jumping record would be in this year? So what year is this? 2013. So if you've kept it like I did after I fixed it, but didn't fix it here to be 64, let me fix it to 64. Then what would your input be into this equation? It would be 13. Okay. If you had left it the way we had before at the 62, like Kayla said, couldn't we have just, and I said yes, then you wouldn't have entered 13, would you? You would have had 14, right? So grab your calculator. I want you to take 11/6, or whatever your slope was for yours on your paper. If it was different, that's okay. Take your slope, 11/6 times 13, and add 64. Typically, you round to whatever the accuracy was originally. So if you take a look at these original values, they're all given to the nearest inch. So it makes sense to round this to the nearest inch as well.
So 80,
yes.
88.
88? Yeah? Excellent. And better put inches because that's how we're measuring it, correct? There we go. Inches. Are we all okay? All right, one last question, quickie. The question is simply asking, are each of those associations, or what can you say, or what kind of associations do you have? So I have three equations of lines here. What is the association for the first line?
Negative.
It's negative. How do you know, Caleb?
The slope's negative.
Slope's negative. What's the second association? It's positive. What we're actually going to say is that there's no association, okay? What we're basically saying is that whatever we're measuring or changing over, let's say the x-axis time, the time didn't affect it. It didn't have any effect on the weight of the children that are obese, or it didn't have any effect on the jumping record, basketball players, or whatever. Okay, so if you get a 0 of flat line, this is a horizontal line that happens when you do this, then you're getting no association. Okay? All right. Let's take a look at